Hey College Algebra, this is going to be a quick lesson hopefully. It's over section 4.1. We're going to be looking at inverse functions, taking inverses of functions, and also before we get into that, we're going to look at what is a one-to-one function. So let's get started on that. Before we get into what is a one-to-one function, we're also going to define what makes a function an inverse function. And it says here, suppose we define the function, this right here is our function. We can form another set of ordered pairs from f by interchanging x and y, and that is what the inverse function is all the x and y values of your function are flipped, are reversed, and that's what makes an inverse function. So this right here, g, ends up being our inverse of our defined function above what f is. So what we have now, okay, and like I said previously, these two functions, the way they're related, they're called inverse functions. They're inverses of each other. And another thing about inverse functions is that they must be one-to-one. So let's look at what one-to-one means. It says in a one-to-one function, each x value corresponds to only one y value, and each y value corresponds to only one x value. So in a one-to-one function, all x values correspond to one and only one y value, and then vice versa. So here we go. Here's some simple examples of what one-to-one and not one-to-one is. Right here, this is one of my examples right here. We can see that our x values correspond to one y value, but this y value right here corresponds to two x values. So that's what causes it not to be one-to-one. Okay? And then this right here, all of the x values in the domain correspond to one y value. And then vice versa. It corresponds back to only one x value. Okay? So we have a one-to-one function there. Another way to define a one-to-one function in its function notation is just like this. We're going to say if f of a equals f of b implies that a equals b, then we have a one-to-one function. And I'm going to show you how to use this definition right here in showing that functions are one-to-one or not one-to-one. Okay. So in this example here, this is what we're going to do. We're going to state this right here. We're going to state that f of a equals f of b, and if this implies that a equals b, then we have a one-to-one function. So plug in on this side a for your x value, so negative 3a plus 7 equals, and then on this side of the equation, plug in b for our x value. All right, now solve the equation, reduce it as much as possible. We're going to subtract 7 from both sides to get this right here. Divide both sides by 3, we get a equals b. So if a equals, or f of a equals f of b implies a equals b, then it is a one-to-one function. So this right here tells us that this right here is a one-to-one function. So one-to-one function. Whoops. All right, let's try the next one. Okay, I'm going to decide whether this function is one-to-one. Do the same exact thing. Solve this right here. F of a equals f of b. And if our equation ends up being a equals b, then it is. So now, on this side, replace your x value with a. On this side of the equation, replace your x value with b. Now we're going to square both sides to get rid of that square root. All right, so once we square both sides, this is what we get. We get 49 minus a squared equals 49 minus b squared. Now subtract 49 from both sides. We get this. Divide both sides by -1. We'll get a squared equals b squared. Now take the square root of both sides to get rid of the square, but remember, one side gets a plus or a minus. So we get a equals plus or minus b. These two sides are not equal to each other, so not 1 to 1. All right, so there we go. So we can use that there, that definition to show that that functions are 1 to 1, but also we can look at something called the horizontal line test, and this is how the horizontal line test goes. So as illustrated in example 1b that I just did, we could see that we already discovered that it's not a 1-to-1 function. And with the horizontal line test, we can determine the same thing. This is not a 1-to-1 function because it's a lot like the vertical line test. If it crosses, if any horizontal line can intercept the graph at more than 1 point, then it's not a 1-to-1 function. So like you see this example, 1b is graphed right here for us. This is what it would look like, and this is not a 1-to-1 function according to that horizontal line test. So let's look at some examples of these. So here's the horizontal line test. A function is 1-to-1 if every horizontal line intersects the graph of the function at most once. So no more than one time. All right, it says determine the graphs. Determine whether the graphs are the graphs of 1-to-1 functions. Okay, look at this first one here. We can see that any horizontal line that we draw through this function, it's only going to cross that graph or intersect that graph once. So this first one is 1-to-1. Okay, this next one, there's many horizontal lines that we can draw, but this one right here, you can see that it intersects it 2 times. Okay, so it is not 1-to-1. This is how I abbreviate 1-to-1, by the way, if y'all haven't noticed that. All right, so let's use that vertical line test in helping us figure out whether functions are 1-to-1 or not. All right, so here's just a rundown of ways that we can determine whether a function is 1-to-1 or not 1-to-1. Okay, so I'm just going to skip this. Y'all can read that. So getting into inverse functions, this is the way you're going to determine if two functions are inverses of each other, is by doing the composition of them. In this states right here, if their composition, f of g of x is equal to x, then that's part of it. Then you have to define that g of f of x is also equal to x. So if both of these compositions are equal to x, then these functions are inverse functions. Okay? Okay, what this is stating here, to determine if a function has an inverse, or finding the inverse of a function, you have to determine if it is 1-to-1 first. So determine if it's 1-to-1. If it is, great, go and find its inverse. If not, then stop right there because it does not have an inverse. Okay, to determine these functions are inverses, then we're going to compose them like I stated before in that definition. So we're going to find what is f of g of x, and what is g of f of x. And if both of these compositions are equal to x, then they are inverses. So for the first one, we are figuring this out. What is f of g of x? And this next one, g of f of x. So what we're doing for the first one is we're taking the function and placing it in for this x value right here. So we're saying we're going to cube the cube root of x plus 1, subtract 1. Well, whenever you cube a cube root, it gets rid of it. So we have x plus 1 minus 1, which equals x. So that checks out. We're halfway there. Do the same thing. Instead, now for this one, we're taking this and replacing our x value in this one. So we're going to have the cube root of x cubed minus 1 plus 1. Well, the 1 minus 1 gets rid of each other, and we have the cube root of x cubed, which equals x. So both of these compositions ended up being equal to x, so these are inverse functions. Okay? All right, so for this example, we're going to do the same thing as the last one. We're going to compose these two functions and determine if it's inverse or not. So I already have written here, let's compose f of g of x, and this is how we're going to do it. We're going to put this function inside of x right here. So we have 2 times 1/2 x minus 5 plus 5. Alright, and then reduce all of this. We get distributing this number. We have, let's see, x minus, oops, not an equal, minus 10 plus 5. And that reduces to x minus 5, which is not equal to x. So this right here lets us know that this function, these two functions are not inverses of each other. We can stop right there. We do not have to compose the second one, the g of f of x. This right here. To determine anything. If one does not equal x, well then more than likely the other one's not going to equal x either. Okay, so a little special note to remember is that we are finding inverses. So say our function is named f here. The inverse function, or the f inverse, is going to be denoted like this right here, with f and then it looks like to the negative 1 power, but do not mistake that. That's what this caution here is down here for, is do not mistake that for to the negative 1 power. It does not mean the same thing. Okay, so by definition, we've kind of determined this already, but the inverse functions, we just switch the x and the y values. And when we switch the x and the y values, well, what this means is what is the domain in our function is the range in the inverse function. And then vice versa. What's the range in one function is the domain in the inverse function. All right, to find the inverse of our function given here, that's just a set of ordered pairs, what we're going to do is first determine if this function is actually a one-to-one function. So go back all the way to where we started in this lesson and determine if for every single x there is exactly one y. And then the other way around. For every y, there is one x. And if you see here, no x values repeat and no y values repeat. Looking at this, no x value repeats itself and no y value repeats itself. So that's kind of what you're looking for. And so this right here is a one-to-one function. And that's the first step in finding an inverse. And then you can find the inverse of this function by switching your x and y values in all of your ordered pairs. So -8, -2. And this doesn't matter much, -1, -1, and 0, 0. And let's see this next one. 1, 1. And then switch 8 and 2. And then we're done. So that is our inverse function. Same thing with this set of order pairs. So on this one, look at all your x values to determine to see if it's a one-to-one function. All of these are different from each other. -2, -1, 0, 1, 2. Yep. And then, but our y values here, 5, 2, 1, 2, and 5. 5 and 2 repeat themselves. This means it is not a one-to-one function. So we can stop here. It is not going to have an inverse function. So not one-to-one, no inverse. All right. So here are the steps. Kind of what we already determined is first we're going to determine if the function is one-to-one. After that point, here are the steps for finding an inverse of a function. You interchange x and y, and then you solve for y. And then once you find y, you replace it with this right here, f inverse of x. All right, so for this first function right here, let's look at the graph of what an absolute value looks like. So if I were to graph this function, this is what it would look like. Looks something like that graph right here. Well, that graph right there, if you remember our horizontal line test to determine if a function is one-to-one or not, it would not pass that horizontal line test. So since this function here is not one-to-one, it is not going to have an inverse. That's what I'm going to state. Not one-to-one, no inverse. Okay, now let's do this next one. Okay, let's look at the graph of this function. I think that's the easiest way to determine if a function is one-to-one. The graph of this function is going to look something like this here. It's going to be a linear equation or linear function. So at any point on this graph or any horizontal line that could be drawn, it is only going to intersect that graph once. So no more than once. That means it is a one-to-one function. And we can figure out the inverse of this function, since it is one-to-one, by doing this. Okay, we're going to replace this right here with a y and interchange x and y. So make your g of x, x, and your x, y. Now we solve for y. So add 7 to both sides. And now divide both sides by 4. We get our inverse function. So final step is don't leave it like this right here. Replace it with f inverse of x, and that is equal to what we solved for. X plus 7 over 4. And we're done. Let's do another one. Okay, so again, we're going to determine if this function is one-to-one, and if so, we're going to take the inverse, or find the inverse. Now the graph of this function looks something like this. Let's see. That's what the graph is going to look like. And you can see that if I draw a horizontal line through this graph at any point along the horizontal, it's only going to intersect the graph. Any horizontal line is going to intersect the graph at most once. So it meets the criteria for the, being a one-to-one function by that horizontal line test. So it is one-to-one. If it is, let's figure out the inverse. Replace this h of x with y and switch x and y. So that's the first step. Switch it. So x here equals y cubed plus 5. Now solve for y. So we're going to subtract 5 from both sides to get this. And now to get y by itself, take the cube root of both sides, and we get y equals the cube root of x minus 5. And then replace our y with the inverse, f inverse of x, and that is equal to this right here, the cube root of x minus 5. And we're done. So we found the inverse. Let's do another example. Okay, in this example, it's a rational function. There's quite a few more steps than the previous two that we have looked at. So in this one, I've already taken one step out for you, which is determined that this function is a one-to-one function. I'm already telling you, it is a one-to-one function. So start with the first step, which is, replace that with y, and now interchange your x and y values. So x equals negative 3y plus 1 over x minus 5. And now we're going to, not x, this is a y. Now, solve for y. We're going to divide both sides by the y minus 5. Not divide, but multiply. So we end up having a cancellation on this side. And then our next step is distribute. So we have xy minus 5x equals. Now in rational functions, we need to gather on one side of the equation everything that has a y in it, even if it still has an x in it, like this term right here. So gathering on one side of the equation, I'm going to keep xy on this side and add a 3y, this right here, to this side. Now I'm going to add the 5x to both sides of the equation, so I get 5x plus 5. Now this is why we gathered the two terms that have y's on one side. We can factor out a y. So we factor out a y, we're left with x plus 3, and that equals still our 5x plus 5. And now what we can do is, to get y by itself, is to divide both sides by the x plus 3. So that cancels out from this side of the equation, and we are left with y equals the 5x plus 5 over x plus 3. And that there is our inverse of f. Goodness, my pen won't write. Inverse of f of x is equal to 5x plus 5 all over x plus 3. And now we're done. Okay, so I have one more example for you, and that is, okay, so the last example I have for you confuses many of my students that I've had in the past, so hopefully I explained it to you well. On this one, we are doing finding an inverse function of a function that has a restriction on the domain. And this is our restriction, oops, right here. So if we were to graph this function, x squared plus 4, it actually looks something like this. But with this restriction that we have, that x is less than or equal to 0, we only have half of it. And since we have that restriction, this function does have an inverse. Okay, so let's go ahead and find the inverse. Replace this with y and interchange x and y. So we have x equals y squared plus 4. Solve for y, we get this so far. Now take the square root of both sides, and when we take the square root, remember there's a plus or minus here. Sorry, not a y. Alright, so this is the inverse function, but that's too much. We only have this domain for it. And if we were to graph both pieces, it would look something like this. Okay, but we only want the part that is, the domain is restricted here to x is less than or equal to 0. Well, that is going to be our restriction for the range on the other, for the inverse function. So we only want the portion where y is less than or equal to 0, which is this portion down here. So it's the negative square root of x minus 4 is what we want. So f inverse of x is equal to the negative square root of x minus 4. And that is it. That's all I have for you tonight. So I hope you'll have a good evening, and I will see you in class tomorrow. Goodbye.